for our online hardware hackathon, Make U of T, this coming reading week from February 19th to 20th. And this is going to be super fun and a super cool flex, so please sign up. Some perks of this hackathon includes tons of prizes and reimbursements. We will be reimbursing up to $150 in hardware per team if you demo. And we also have huge monetary prizes for winners, which goes up to $2,500. Our applications are closing in 3 days on Friday, February 5th. So make sure you apply on our website at makeuft.ca. If you have any questions, feel free to shoot us a DM on Instagram, so at IEEE_U of T, or an email at IEEEUTstudentbranch@gmail.com. So sign up, guys, and thank you so much and have a good lecture. That's all for me.
Hello, Smile.
Yeah.
Would it be possible to put the link in the chat maybe if students are interested in following up?
Yes, for sure. I can also send this graphic in the chat as well. But thank you for having me.
Thanks, Mal. I'm just doing a final bit of setup, getting my microphone hooked up. So if there are any questions, type them in the chat or unmute. Got a few seconds anyway.
Has there been any decision about OP1 or OP2 in terms of in-person or online?
We are thinking in person. That is the plan, and hopefully we will get there.
Okay, thank you.
Okay. See, so yeah, one big announcement that I imagine you've all heard about is we're heading back to in-person learning next week. So the lecture will be in person, and let me just get this recording going a bit better. So the lecture will be in person, as will the coding tutorials. And maybe Ken, you want to talk, and so will the labs. Ken, maybe you want to talk about CI meetings.
Yeah, we're at the moment. We're planning that the CI meetings will continue on Zoom, but we're looking at the possibility that we may be able to introduce some live sessions, particularly for CIs who are comfortable doing this. And as we get past reading week, if we seem to be going in a good direction health-wise, that maybe we can start to find ways to get back to in-person meetings. So a little bit of uncertainty at the moment, but we're certainly paying attention to this pretty closely.
Okay, so just to summarize, we're in my hall for lectures next week. We'll work out Ken and I will work out some method to videotape them to put on online afterwards. Might be a few bumps in the road. Same thing for tutorials in person. We'll make an announcement on Piazza of which room they're in. We're only going to be in, some sessions have 2 tutorial rooms booked. We'll only be in one of them. Again, we'll find some method to tape them so we can post that afterwards. Lab session in person as well. Obviously, if you don't feel well, don't come in. Just contact your TA either right away if you're feeling up to it, or later if you're not, and we'll work something out. And CI meetings remain on Zoom. Dr. Tallman and I are trying to work out some arrangements where maybe there'll be some rooms that you can go to so you have a place to have that Zoom meeting. So that one is still a little bit in flux. Okay. If there are questions, let us know. So last few comments about teams, and then I'm going to go on to testing today. So within a team, conflict is going to happen. Almost always you have some conflict. You want it to be, though, well, it doesn't have to be a conflict. You're going to need communication. Problem is going to arise, so it doesn't have to be a conflict. You're just solving the problem. Sometimes it can turn into some amount of conflict. How do you deal with that? So we talked about that some last week, but let's just talk a little more with an example. So this is almost certainly going to happen to your team this semester. Somebody's going to break the build. So breaking the build means somebody put back code to the remote repo that doesn't work. And not only does it not work, it's actually holding us up. So Ken has put back code, I think. I do a pull, I get the latest code from the remote repository, I try to build it, and there are compiler errors. So I send Ken this email because it was holding me up. Ken, the build is broken, can you take a look? So what do you think? How's this communication? How's my email? So type in the chat, or you can unmute yourself and actually speak out loud. What do you think of this? Okay, so Zaid's saying, not very specific, doesn't explain what's broken, which build, more detail. Okay, so some simple and compact. Doesn't say please, so maybe I could be a little more polite. So, okay, so it's short, people like that, but they're also, it's not that detailed. So, Ken, what do you think? Do you think this is good?
Well, it sort of, as you say, suggests that I broke the build, but maybe I didn't, right? It's a little unclear about where the problem actually started, and it's making an assumption that I'm the problem. So I might feel a little bit upset about that, and yeah. And can you take a look? Is sort of okay. It's maybe a little bit too loose. The language. It's not a very polite request. I might say.
Yeah. Okay. I'd also say the context matters here. So context. So I haven't given you enough information. The context matters in that if Ken and I are a very high trust team, then we don't actually have to worry as much about a lot of politeness and evidence. We probably trust each other. Ken may have the attitude, if I say the build is broken, he actually infers from that, this is holding me up, he should look at it right away. And there's a good chance that it's his fault because usually I'm pretty careful. So maybe in a high trust environment where we've worked together a lot, we can use very succinct communication like this. I haven't, but initially at least, when we're working together, this is probably not enough. Okay, because I'm not very specific about exactly what's broken. So, Ken doesn't know what should he check, right? There's no evidence that it's his problem. Not doing him the favor of saying, here's what's happening. Can you take a look? I haven't been very specific about what I want. There's no sense of urgency. So this could be okay if I don't really care if he does this in any particular time frame. But let's say the context is actually holding up my work. I need to get something done, and now I've got these compiler errors. I have not communicated that urgency to him, and I haven't said, I need you to tell me if this is something that you did or not, and I need it pretty soon because it's holding me up. That's not here. Okay, so let's try a different one. Maybe it is holding me up. I got to get a fix right away. So I ramp it up. Okay, so what do you think of this one? Ken, once again, you broke the build. Abbott and I can't work. This is unacceptable. Fix it now. What do you think? It's pretty aggressive. Okay, yeah. So I see people going, that's okay. The other one might have been a little too laid back. This one's pretty aggressive. Ken, what do you think? Would this work perfectly with you?
Well, as I said, it's a bit aggressive, and probably would create some hard feelings. Yeah.
Yeah. So, and email actually amplifies conflict. So when a person is reading this, they don't know what facial expression you have. They just see exclamation points, etc. So email can create more conflict than you think. So you want to be pretty careful about how you phrase your emails. So this one's not good. Okay.
Or did Vaughn? Oh, there he is.
Yeah. Sorry. Go ahead. Oh, sorry. Did you lose me? Hopefully you guys can hear me again. It looks like my internet connection is a bit unstable. So on the plus side, I am conveying that it's urgent and that I want something. Okay, let's see. Looks like I'm losing my internet connection. Can you guys see this or not?
There we go.
I think you're muted, Vaughn.
All right, it looks like my Wi-Fi went flat out completely down. So sorry about that. I'm back. Let me see if the recording is working again. Ken, can you hear me okay now?
Yeah, I can hear you fine, Vaughn.
All right, sorry about that. I don't know what happened, but I had a complete internet drop. It'll be kind of nice to be back in person, where I'm less likely to just collapse to the floor. Okay, so on the plus side of this one, I have conveyed the urgency. This is a problem, and I need you to fix it right now. So there's one plus here. On the other hand, there are a lot of minuses. I still haven't given any evidence that it's Ken's problem, and it's kind of a bigger deal to give evidence now because I'm being pretty aggressive about this. The tone of this is all wrong. So it's angry, it's condescending. There's no upside to doing that. You have to think in your communication. You have to be deliberate in your communication. Again, in a very high trust team, you can get a little more casual about this because you've worked together a long time and you can kind of use a shorthand. That's part of what makes your team very efficient. You don't have to worry about it as much. But that's not where you guys are starting out. And in your career, there'll be lots of times where that's not where you are in a team. So you got to be more careful. Don't ever use a tone like this. Okay, what about this one? So hi Ken, there are many compilation errors in streets.cpp. Last commit to this file was at 8 p.m. last night by you, so we think it's your code. This is holding Abaddon and me up. Can't compile. Please take a look as soon as possible and let us know when you can fix it. If it can't be fixed the next hour, we'll have to revert your changes. Okay? And I even said thanks. So what do you think of this one? Okay, so people think it's a lot better. Ken, what do you think? Well, Bailey thinks it's a bit long. Yeah, it is a bit long. So it's less succinct. It's true. Ken, what do you think?
Yeah, no, this I feel pretty comfortable with. I'm thinking that you've established that the last commit was at 8 p.m. It was me, and so I'm probably the problem, and so I feel like this is reasonable request, and also kind of has enough urgency to get me focused on it, yeah. But is certainly more considerate.
Yeah, and it is getting across what I need and why I need it. Now, I agree with the people who say it's a bit long, right? So what I'd say is this is the failing of this. Well, let's click on this. So I guess good things, specific problem, evidence that it's Ken's. So I did my homework. That's actually also not wasting Ken's time. I didn't just fire off an email without doing any investigation. I did some. Talked about why this is a problem and what we need. I put a deadline on it. Okay, not in a really nasty way, but deadlines are really important in projects. This is actually holding us up, so we need to fix the next hour. Maybe Ken's busy, maybe he can't fix it. In that case, we'll revert it, which is going to make more work for Ken, so we've given him a heads up. But this is a very reasonable way to do this. I can't say I'm just going to wait forever. Maybe you're not even going to see this email, but I'll give you a little while. The thing about length is a good point. I think what I've fallen into, or what I've done is not the best, is I've kind of buried the lead and made to stick terms. I talk about kind of the evidence, why do I think that this is your problem, but I probably should have started with what I need, okay? There's a build failure that's holding Abbott and I up that we'd like you to look at. The first sentence could tell Ken what he needs, and if he reads that first sentence and goes, oh man, I think I actually forgot to run any tests. That sentence might be, I just forgot. I didn't actually build and test. That might be all he needs, okay? So it's more efficient communication. On the other hand, if he goes, well, wait a sec, what are you talking about, and so on, then he reads the rest. Goes, oh, okay, maybe that is my problem. Okay, I was editing that file, and I know what you want. Okay? So yeah, the tone is, I think, appropriate. It's respectful and polite, but it's clear. It's not maybe you could help me a bit. It's like we need this by this time. And as I said, I buried the lead. I have to write emails like this all the time in running a course. I had to write them when I was at Altera. I know one of my former PhD students said he was kind of amazed at how when I was writing emails when we were for various things. He helped me run this course for a few years. that I would be very careful about reading it and seeing what are various ways people could misinterpret it. Because when I was in a company sending mails off to teams around the world, if I need this or I need that, they had to be very clear or we weren't going to have projects converge. So you want to be clear. Okay, so common source of conflict in this course and actually in your career is people not meeting their commitments. So what are you going to do? You've been working away on this project. Your partner has missed several commitments. You needed certain functions to be done by certain dates. You agreed that's what would happen, but it hasn't happened. Okay, so how are you going to handle that? So I'm going to put you in breakout rooms, have you brainstorm that a bit. When you come back, we'll get you to type some suggestions into the chat or say them, and then we'll discuss them here. So let's see. Okay, welcome back everybody. So hopefully came up with some good ideas of how to handle this. Why don't you type some of their ideas in the chat? What would you do? Okay, so I see a good answer from Sage here. So make rules to avoid this problem. So good idea. Set some norms. Emergency placeholder. Write a placeholder. So stub it out. Make something that stops the build from breaking. So that makes sense. Work around it. Make work arrangements to resolve the real problem. Assign someone else to complete the code. Makes sense. If the code's impossible to be completed by a milestone, make a feature branch so you keep working on it. And try to talk about it. Talk to a teammate to try to figure out why it didn't work. So yeah, all good ideas. Lily says, talk it out personally first. Then if it keeps occurring, talk to a TA or prof. So that's a good idea. So you gradually escalate. So when you have someone not meeting commitments, again, this happened to me all the time in industry. It's a common part of management. You kind of gradually ramp up the feedback. So you start with a conversation with the person that's, okay, so what happened? It happens again, the conversation is a bit stronger, can be escalated to your TA, which is your management, all appropriate. Let's start with talking to the person first. Nicholas says, figure out why it wasn't completed, ask them to finish it, otherwise notify people to work around it. And possibly for fairness, have them do it again. So all those are reasonable comments as well. Bailey says, talk about reasons, talk about urgency, talk about the solution, and maybe send it to the gulag. So yeah, I like the way people are thinking. They basically talk about it, which is key. Try to understand why it occurred, and then discuss, okay, what are we going to do next time? How can we prevent this from recurring? So those are really good ideas. And whoops, I clicked on the wrong button. Put down some of my ideas here. So most of you talked about, put this down, so that's great. Talk about it. And actually, it's best to do this. You can start an email, but talk about it in person, or if you can't do it in person, over Zoom. Email magnifies conflicts. When you're trying to work out a conflict, better to do it in person. Okay. Try to be factual, not emotional. So Made to Stick talks about use emotion and then people remember things. It's true. We're talking now about a situation where there's conflict. So people will remember that conflict more strongly, more strong negative feelings about it if it's emotional. So you try to take the emotion out. Not a lot of, you made me angry, you made me feel this way. I cannot accept this. And a lot more facts. So, okay, let's talk about what happened. Let's talk about how to avoid it. And you have to resign yourself to, usually maybe it goes away after one conversation, but often it takes multiple conversations. So that's part of managing situations like this, is being persistent, being patient. It's good to write down the outcome on the wiki. So after you're done talking about it, you write down, okay, we missed this. This is what the team's going to do. Maybe we need less aggressive commitments. Maybe it wasn't clear that this was that teammate's problem. You know, they had to make that. Maybe the deadline wasn't clear. You thought it was late because you're depending on it. Teammate didn't understand that. Teammate thought, I still got lots of time. Okay, so write down how you're going to do something differently next time. Often an outcome is that essentially you've been too casual. You didn't have clear responsibilities, clear tasks for this teammate, maybe for the whole team, and you didn't have clear deadlines, and you weren't updating how is it going. So if that's the case, you can have a misunderstanding. Teammate still thinks I've got lots of problems. Teammates are getting really worried and saying I'm going to take away the task. Even if the person doesn't meet the deadlines the next time, the fact that you've written it down has made clear the team expectations. Should you talk to the TA and CI? Yeah, if it's not resolved, you should. But you want to talk to the teammate first. So you don't start with that conversation. That conversation comes after talking to the teammate. If you've already talked to the teammate and then, you don't hide this. Writing down the outcome, we missed some deadlines on the wiki. It's part of your project management and your TA should be able to see it, but your TA would expect you to have already talked about it as a team. If the problem persists, you keep writing down that it's persisting, because sometimes what happens in this course is we will wind up with unequal marks for team members because somebody's not contributing. So sometimes you even when you explain the importance and you write down the commitments, a teammate still doesn't carry his or her load. That's actually the best you can do in that case is everybody understands what's happening, and the TA understands what's happening. The TA will then reallocate some marks, and usually the teammates who's getting lower marks are actually okay with it too. They're like, yeah, it's fair. We split up the work, and I'm not carrying my part of the load for all sorts of reasons. That's happening over and over again. My teammates should get more marks than me. So they don't always agree with that, but often they do. And again, this is the way I would manage performance in industry. So I have people, what happens is this feedback gets stronger and stronger if a person keeps having trouble delivering. That's what happens in industry. Best practice is talk about it early, gradually ramp up and if it's resolved, then it's fine. That's great. But if it isn't, you talk about it in stronger terms, more clear deadlines, and eventually in industry that escalates to, look, you need to meet these commitments or your performance is unacceptable and you will be let go. And that did most people. They didn't get to that point, but it did happen sometimes. And some of the people that, pretty much everybody that I had to fire, in the end, while that is not a happy day for them, they respected how they were treated. So what you want is even when it doesn't work out that well, that you've been transparent, you've given people a chance, and they respect how they were treated. So I would say this is best practice in how to manage a teammate not meeting deliverables. Okay, Ken, any final thoughts on this? Does this kind of line up with the way you do things as well?
I would just echo your thoughts, Vaughn. I think that doing it early, addressing the problems when they come up. If you let them fester, it gets worse. And in a course like this, where we've got such limited time, address the problems as they come up. And that's, I think, a key to getting through and finding ways to work productively as a team.
Yeah, and definitely don't let yourself get into a situation where it's late in the course, you've papered over problems where some teammate wasn't contributing, and now you talk to your TA or Dr. Tallman or myself saying, I'd really like to go back and take marks from that teammate, or I want that teammate kicked out of my group, but I've never had a conversation with that teammate about this, or not a very direct conversation. But we're going to go back to this slide and say, you didn't do this, you need to start doing this. We really mean it. Okay, let's move on to a different topic, testing. So your philosophy in testing code is that if you didn't test it, it doesn't work. So you assume that all code is broken until it's proven otherwise, because that is the usual case. I write software and it doesn't work at first. So I'm not surprised at all by that. So you look at what the program does, not what it's supposed to do. So sometimes when I'm in the lab with students, they'll say, well, the code should do this. But I say, well, what is it doing? Because it's not doing that. And then they keep telling me what the code should do. So that's not the right way to think about it. When you're testing, you just observe. What does the code do? You're testing hypotheses about the program. And we'll have a tutorial next week on debugging where we show you some techniques in more detail of that. think of all the cases your program should handle and make sure your tests cover them all. It's okay to test multiple times, have overlapping tests. That's perfectly fine. You do not want any gaps. So if you're not sure if a test covers it, make another one. Okay, when do you test? So you should develop tests early. So develop tests while you're developing the code or even before you write the code. So if you write, this is called test-driven development. Test-driven development, when the strict forms of it are you actually write the tests first because they are basically your specification, and then you actually write the code. Often that's weakened. You kind of write them both at the same time. You kind of cycle between writing some code, writing some more tests. You don't want to write them all at the end. You say, I'm writing all my code, and then someday in the future, maybe that day will never come, I'll write a bunch of tests. Not a good idea. This also is what drives agile development. So agile development, remember, we create a prototype quickly, we test and evaluate it, we refine it, we keep going around that cycle over and over again. So we need to make the tests early. We can't wait to some future date to do it. In the waterfall methodology, there's more of, it would be okay to make a lot of these tests at the end. Agile says, no, don't do that. And it works better to make them earlier. With test-driven development, the tests become the detailed specification, and they can be executed, not just read. So you wind up with less specification documents, rules of you're allowed to have this word but not that word, and so on. And you still have some of that, but you wind up with a lot of the detail of the specification can be moved into tests. And the good thing about tests is they're unambiguous. You can actually run them and they either pass or they don't. Whereas as specification documents get very long, it's hard to say if they're complete, and it can be hard to say, did I actually meet the specification or not? So you're still going to need some specifications, but try to make it executable. Make tests that check it. Okay, types of tests. You're going to have system tests. System tests are end-to-end tests. It's probably what you've used, well, it is what you used in ECE 244 and APS 105. So they test your design in the same way an end user does. So it sends an input to the program and it checks the final output and it sees if it matches what it expects. You can also have another style of tests, which we will use in this course, called unit tests. And unit tests test small pieces of a system, and they can test even single classes, single functions. So they can test very small pieces of a system. Okay, and I've drawn them as a pyramid. Maybe we'll talk in a minute about why I've drawn that. So maybe just in the chat, I'd like you to type in thoughts of what are the strengths and weaknesses of system tests, what are the strengths and weaknesses of unit tests. We should actually have some of both of these, so I'll kind of give away the answer. There's no, oh, I want one of these but not the other. You should have both. What is each of these good at? So I just type some thoughts in the chat. There must be someone who's got an idea. So speed for unit tests. Yeah, so that's a good point by Ankit. So unit tests, because they're testing small functions, they tend to run fast. An even bigger advantage of unit tests than they run fast is once they fail, you have a very good idea of what failed because they're testing a small amount of your code. So they're much faster to fix. Okay. System tests, people are saying, are more comprehensive. They check how many people or how your whole system fits together. So they're more comprehensive than a unit test. That's definitely true. We want to have some system tests because otherwise maybe there are gaps in our unit tests. All the little pieces work, but when we put it all together, it doesn't do what a person would want. Yeah, I see Charles saying the unit test is easier to debug and they're more precise. That's true. Those are the strengths of unit tests. So yeah, I'm just writing down some of my thoughts on that, which basically match what you guys have said. System tests test the whole system, no gaps. So we want some of them. We do not want the end user to be the first person who's testing the whole system. That would be insane. Downsides, they're hard to debug. Okay, so a system test fails. The bug could be anywhere. Your whole program was involved in creating that output. They're also fragile, or they can be fragile depending on how they're coded. So they expect the simplest way to write system tests, which often is what people are doing, is you take a certain user input and you save it, and then you send that into the program and you produce some output, and you check, did I get the output I expected? That can be quite fragile. If you're actually checking this input produces that output, small changes in the program that are not really bugs, even just formatting changes might make that fail. So there are some techniques to make them less fragile, but it can be a problem with system tests. Unit tests, much easier to debug. So if they're just testing a single class or a single function, if it fails, it's obvious where to start looking. And you spend most of your time debugging. So making that more productive is a big deal. They're less fragile. Unit tests, we don't check, typically you don't check the user interface. Like you don't actually do I/O into the program. You instead you hook straight into specific functions and you check those functions or that application programming interface to make sure it does what it's supposed to do. And that can be less fragile. Now, they don't test the whole system, so there could be gaps. So you do want some of both. And I see Sage saying, you know, why do we have a pyramid? And the reason we have a pyramid is we actually do want to have more unit tests than end-to-end tests, okay? And there's usually something in between too. So integration tests are basically bigger unit tests. They're written the same way as unit tests, but instead of checking one function or one class, they check essentially groups of them. So they're kind of in between small unit tests and end-to-end tests. They are usually written using unit test techniques. So they're still called unit tests, they're just bigger ones. And they kind of lie in between. They cover some of the gaps that your little unit tests would have, that they're somewhat harder to debug because if they fail, it's less clear where to start. Okay, so you wind up with more tests at this simple level because they're easier to write, they're just testing a little bit, and more importantly, they're easier to debug. And then you build some integration tests that test more of the system, and then at least a few end-to-end tests. And if you fail some tests, you start here. You make all of these little unit tests pass, and maybe now the end-to-end tests also pass. These unit tests are much easier to debug. So only once all these unit tests are passing do you kind of look at the integration test failures, and once those are passing, you look at the end-to-end tests. Because these ones are much more expensive to debug, you're hoping there's no bugs left by the time you fix these other ones. Okay, so we want these unit tests. Yeah, so Julian's asking, is public M1 load maps an integration test or a unit test? So they are all written as unit tests. Some of our unit tests are smaller than others. So you could classify some of our unit tests as kind of integration tests. For M1, most of them would be considered kind of classic unit tests. The load map's a bit bigger because you're right that there's a bit more functionality in that. Okay, so how does this work? So how do we test these individual classes and functions? Okay, so should we just carefully choose the user input? So here's I've got a keyboard, I've got a program that I'm trying to exercise, and I actually want to have a unit test that checks if there's some class inside of it called point. It's got an X, a Y, together that forms a two-dimensional point, and we've got this multiply operator. So I've overloaded the multiply equal operator, and I want to check if that works. So I'm going to make my unit test by carefully choosing what the user input is, what you would type, and checking some specific output that comes out of my program and making sure that it works. And if that fails, I know my problem is in this point class. What do you think? Is this a reasonable way to try to make a unit test that check that this point class works? So if you're waiting for a chance to answer a question, it's just a yes or no one, you take a shot. Is this a reasonable way to try to make a unit test for this point class? Okay, Sage says reasonable but less coverage. Like, so is this feasible? In a large program, do you think I can choose some input where if this test fails, I know that it's the point class that failed? So in general, in a large program, this is just not feasible. I can make a test, but it's basically if it fails, I don't know that it's this point class. It went through a ton of code. Could be my input, could be output, could be point. I have no idea how many classes are involved. Very hard to craft this. So that's not going to work. That's not how unit tests work. So what you do for a unit test is you write code that is your test code. The code has to put the class in the right state, has to directly send it some input and make some calls. Immediately it checks the responses. So it's a test driver. So in that point example, this is the code I want to test. I want to test this operator times equal. So I write some more code, and I put it in a different file, call it tester.cpp, and this basically constructed a point, it called that operator that we want to check, and it checks what the output should be. So if our original point was at x equals 1, y equals 2, after multiplying by 3, it should be here. If I'm not there, I return 1. By convention, returning a positive number, that's how many tests I failed. Otherwise, I return 0, meaning I didn't fail any tests, so that's good. Okay, so I wrote all that. I should have lots of unit tests. So now I also write another main file. So let's call it test main.cpp. It's got an actual main function, so a start point for my program. I say I've got no errors, but I'm going to add in however many errors I got from this test point times, and I'm going to write a whole bunch more tests for a whole bunch of other things. So there'll be lots of lines here. Okay, so when I build my actual program that I would send to end users or demonstrate to my TA, let's say I've only got 2 files. I've got this my code that has this point in it, and I've got main.cpp, which is my main function. And I basically say I want to make something called program.exe. That's what I'd actually expect an end user to run. I actually build a different program when I'm trying to run my unit tests. So I compile this my code again. That's what I'm trying to test. But I actually compile a tester.cpp file. That tester.cpp file has, my test code in it. And I compile this test main function, or test main.cpp, and I build a different executable called test.exe. So I've actually got a different program that doesn't do anything an end user would ever want to do, but it tests my functions. Okay, so that's how unit tests work. You actually build a different program that tests your functions. Okay, so let's talk about that in your project. So I'm going to explain the directory structure of your project a little bit. So you have a directory called mapper, and inside that you've probably already noticed there's a main directory and a libstreetmap directory. And both of them has source files underneath them. The source files underneath main, and there's one that's given to you called main.cpp, will be used to build the end user program, which is called mapper for your project. So that's what you'll, in Milestone 2 and Milestone 3, you'll run that when you want to do demos for your TA. Most of your code is actually going in this libstreetmap. Okay, it's going to be built into what's called a library. A library is essentially a collection of object files, so machine code that can run, but it doesn't have a main function. So it's not a complete program. It's just a collection of object files that can be useful to programs, but it's not a program by itself. So that goes into something called a library, which in Linux ends in .a. So libstreet.a is like a piece of an executable program. Your mapper, when your TA is running it in Milestone 2, Milestone 3, that executable program is basically making all sorts of calls into libstreetmap.a. So you can kind of consider, your mapper includes this library. It's part of the executable. But the reason we've put your project in this structure is this not the only thing that can talk to libstreetmap.a. So when you run ECE 297 exercise, that is a program that has a whole bunch of unit tests that we've written. They're directly calling your functions and checking the outputs. And it's actually calling into that same object file. You can also, there's a tests directory in your project, and you can write CPP files in there if you like, and those will be compiled into a different executable called test libstreetmap, which also talks to your libstreetmap library. So libstreetmap is your main, that library is really the main grouping of code that you're writing. So these unit tests in test libstreetmap, can be tests that you wrote. So you can write tests in there. You don't have to. So in Milestone 1, we say you can write tests if you want, but you don't have to. We provide a lot of tests and exercise. If you want to look at the tests, you want to actually look at the code that exercise is running, and you particularly might want to do this if you want to run it through the debugger. All that code is visible. You can copy it over from the directory I've listed there, put it in your NetBeans, put it in your source files, and then build this executable. And now you can run the debugger on it. And we'll talk about that in the tutorial next week. So we'll actually demonstrate exactly how to do that. You can build all of these things at the command line. You can also build them through an IDE GUI. So in NetBeans, so far we've told you how to build the release, the debug, and the debug check build. All those things build this library, and they build your mapper executable. If you want to build this test libstreetmap, you can use these build types, and they'll again build the library, but now they'll build this other executable that just runs tests. So both those things are useful. And ECE 297 actually is essentially as a convenience will just run the unit tests for you without you doing anything special when you build. Okay, there's a question of do you have to build your own tests? No, it's optional for this milestone to write your own tests. You can, but you don't have to. Okay, so let's talk about unit test frameworks. What I've shown you is how unit tests work. When you make unit tests, you wind up with a lot of repetitive code to create those test drivers. There's set up the test, check if it passed, run all the tests, output the appropriate messages, collect statistics. You could write all that yourself in C++. But because it's kind of repetitive, there are unit test frameworks which basically define some macros and some functions and sometimes some classes that simplify coding. They just make it a little bit less repetitive. We are using a unit test framework called Unit Test++. It's a fairly powerful unit test framework, but it's pretty easy to learn. There is a quick start guide on how to use it and how to run unit tests through a debugger. So you can go check that out. So what's in a unit test framework? So setting up the test, you will see for Unit Test++, it has macros called test and test fixture to set up the test. It has macros that help you check, did it work? So I can check the values, I can check the time. So it's got macros called check. It's got a function call you can make called run all tests that just runs all these tests that you've written. Outputting the appropriate messages, it does automatically. And collecting statistics, it does automatically. So there's nothing magic about it. It's basically just written a bunch of C++ code for you so that you don't have to write quite so much. You still have to write the tests, but this takes some of the drudgery out of it. Okay, in testing, you want to be paranoid. And an example I'm going to use here is the 737 MAX, which was clearly a horrible testing failure. So the 737 MAX had 2 unnecessary crashes and 346 deaths before going through, being grounded, going through an extensive redesign and re-verification to show that it was actually safe to fly again. And if you're interested, this is a Globe and Mail article by an aerospace engineer in Los Angeles, I believe, who goes through a very nice detailed summary of exactly what happens. This is the best summary that I've seen of what really happened. So I can't go through all of it, but I think it's worth reading. So what can we learn about this as a case study in design failures? So the context of this is the 737 MAX is a new version of the 737 that has larger engines. Basically, there's a new style of jet engine called a geared turbofan. It's more efficient, but it's physically larger. It's really expensive to make a new new plane. So Boeing, instead of making an entirely new version of the 737, said we'll take the old version and we'll just put new engines on it. But those engines, because they're larger, are in essentially the wrong spot. They make the aircraft aerodynamically unstable. It wants to pitch up. The nose wants to go up. And without redesigning where the wings are and redoing the whole plane, they couldn't fix that. So what they did instead is they put a sensor system and software called MCAS, which I think is Maneuvering Control Automatic System or something like that, to stabilize it. So what it would do is it took a sensor to detect essentially based on the airspeed and the pitch, am I approaching a stall? Stall is where basically you lose lift on the wings because your pitch is too high, so you don't want that. So the sensor would detect that, and automatically the controls of the plane would be adjusted to pitch the nose back down, right? So the elevators would be changed, so the nose would pitch back down and the plane is stabilized. However, it was designed poorly. There's a single point of failure. So they actually had one sensor. If that sensor gave the wrong reading, this system is going to do the wrong thing. And it's a safety critical system. So that's their first design failure. You should never have a system that's critical that has a single point of failure. They should have had multiple sensors. They should have had voting, etc. The second point of failure was that the software system was not tested with a broken sensor. So this is where you have to be paranoid. Think of all the things that could go wrong, especially in something safety critical like this, and you make tests for all of them. They didn't do that. And then a third failure was that the documentation and the pilot training assumed that the system worked. So pilots could override the system and then take control and stabilize the plane themselves. But the documentation for that was confusing, buried, and not emphasized, because Boeing did not want airlines to have to retrain pilots. That's expensive. So they said you don't need retraining. You just need a short update. But that was bad. That basically meant that this system was downplayed and the pilots didn't know what to do if it kicked in and started behaving badly. There was a cultural failure at the heart of this. Safety was compromised for sales. So some Boeing engineers knew they were taking risks. This wasn't the best way to do this, but it was saving them billions of dollars. And there may be times in your career where you actually have to try to put the brakes on something that you think is unsafe, and that that takes some courage. But failing to do it can result in situations like this. So, okay, so I recommend you go read this article. It's interesting, and the time in your career where you're asked to do something unsafe, you don't know when that'll happen. So it's useful to look at things like this in advance. There was at least one time in my career where I can think of where I was asked to do something that I believed was unsafe. It was basically not fixing a bug in our software where, when I was at Altera, where that once in a while we could say the chip would run faster than it could, and those chips were going in things like planes and so on. And because it wasn't desired to communicate that failure to the customer base, marketing said, do not fix it. And I basically decided I could not in good conscience do that and said, we're fixing it, and I am not changing it back, right? There is no, you're just going to have to try to get somebody who's high enough up in the company to fire me. So this does actually happen in your career sometimes. You don't know when, but you want to be prepared that you have to do the right thing in those cases. Okay, testing tools. So I'm going to go a few minutes over. If you have to go, it'll all be recorded. What tools can we use to test? So we've already given you this debug check build. Use that. Automatic checking of memory. And the debug build helps you because now you can use the debugger. So test fails. Look at the code for a little while, and then you got to bring it up in the debugger and start seeing what happens. So I often see students on Piazza saying, I've been looking at this code for the last 3 hours. I can't figure it out. Can anyone help? You should never post that. You shouldn't be looking at code for 3 hours. You should have said, you should have fired up the debugger. Now, if you say, oh, okay, I looked at this code, and then I ran it in the debugger for the last 2 hours, and I still can't figure it out. Okay, fair. But don't say you've been staring at it for hours without running the debugger. I actually like to use this to verify new code. So even before I have any bugs or failures, I run the code through the debugger so I can actually watch what happens, and that gives me more faith in it. Memory checker. So I guess I did this in the opposite order. If your program's behaving very strangely or it's seg faults, seg faults definitely mean you're accessing memory you shouldn't. If it's behaving really strange, like you just can't find any rhyme or reason for this, then you may be corrupting memory but not seg faulting. Use the debug check build or use valgrind. And they will now check what your memory access is. They can often find problems for you much faster than you would yourself. Okay? And yeah, next week we'll actually go through a walkthrough of debugging techniques using the debugger, using the debug check build on actual code from Milestone 1. So we're going to take some Milestone 1 code that we wrote. We've inserted a bug in it. We're going to show how to find it. Other testing tool, code coverage. Not going to use it in this course, but useful to know about. This is a tool to tell you if you have enough checks, enough tests. So they track what lines of your programs have executed over all your tests. So let's say I have this is my code, not a very useful function, but basically if the input is 0, it returns the number 3, and otherwise it returns the number 7. And let's say I want to test that. And I write this testing function. And my testing function, I just call this function with the number 8. Which is only going to go through this. Let me erase this. If I call this with the number 8, it's only going to test this if statement and then go into the else. It'll never execute this line of code. So I don't have enough tests. I never went through this line of code. What if it does something weird? Never check that case. A code coverage tool basically keeps track as all your tests run which lines of code have ever executed. So it would say that your code coverage is 6 out of 7 lines or 86%, but you've got nothing that ever goes through this. Probably want to make more tests. Okay. I was visiting some friends at Google a few years ago and had to go to the washroom. And when I went to the washroom, it was interesting. On the toilet door stall on the inside was basically a sign like this, okay? Testing on the toilet. Every week at Google, they would change these little one-page testing tutorials that they put on the inside of the toilet stalls, on the inside door. So the idea is everybody's got to go to the washroom at work, and we're going to use that time to teach them a bit about testing. And it's because Google considers testing so important. It's actually also an interesting example of communication. This came about because a bunch of engineers at Google decided that as the company was growing, that they were losing some of their software quality due to people not understanding how to test well. And they came up with the idea of, well, how can we reach people? They're all busy. How can we teach them about this? And well, everyone goes to the washroom, right? We're going to just basically create a grassroots effort where every week we come up with a little tutorial and put it in all the cubicles, toilet stalls throughout Google, and we're going to teach people this way. So it's also a good example of clever communication. Okay, last thing I'll say about this is you want to make it really easy to test and build. You're going to do it over and over again. So in ECE 297, you probably noticed there's one command to build your whole program. You type make, or you can click on build in an IDE. There's one command to test. You type ECE 297 exercise, and there's one command to submit your code. So that's on purpose. The prior infrastructure for this course, before myself and some of my grad students rewrote it, these took many, many commands, and you had to organize things in certain ways. You don't want to do that because you want to make it easy for people to test so that they're doing it all the time. Again, I'm using Google as an example because they do a lot of best-in-class software engineering. They also make it very easy to build, to test your software. They go one step further and they make it easy to deploy. So by deploy, I mean actually send it out to their customers so they can do, you know, that last stage of agile development. So that ideally you're actually testing with customers. So they're very good at that. So you can make changes to, for example, their search engine, and you can send it to the real website where real users are using it, and they can split the traffic. So for example, they can send 2% of web traffic to a new search engine or a new ad engine, and they can collect statistics to see does it seem like it's working better or worse. So one of my friends at Google said, he made a change that changed a part of how their ad engine worked, and it actually, Google's scale is so big that this actually made them tens of millions of dollars. So he was quite pleased with that. A couple of weeks later, he made a different change, and it got sent to 2% of their web traffic to test it out, and it was worse. And by the time they pulled the plug, it actually had cost millions of dollars, but that's okay. This is part of Google's philosophy. You know, we tested the one, it worked well, that made tens of millions of dollars. This other one, you know, cost us a few million, but that's part of our continuous improvement philosophy. So continuous deployment like this, what Google is doing, requires really good automated tests. So clearly you don't want to deploy your new code to the web server and just, it's crashing all over the place. So you got to have really good tests. Okay, I'm not going to get to coding style today. We're going to talk about that on Monday. And I'll hang out here on the line in case there are any questions. Thanks.